This recording is going to be section 11.1 sequences. A finite sequence is a function whose domain is 1, 2, 3, and so forth, n, the positive integers less than or equal to a fixed number n. An infinite sequence is a function whose domain is the set of all positive integers. The function f of n equals n squared with the domain 1, 2, 3, 4, 5 is a finite sequence. For the independent variable of a sequence, we usually use n instead of x and assume that only natural numbers can be used in place of n. For the dependent variables f of n, we generally write an read a sub n. So this finite sequence is also defined by an equals n squared, where n is between 1 and 5. So function notation will be f of n equals n. F of n gets replaced with a sub n equals for n squared in this particular case. The terms of a sequence are the values of the dependent variable an. We call an the nth term or the general term of the sequence. Find all terms of the finite sequence. Our first example is we have n between 1 and 7, so we're going to list 7 terms. A1 means you're plugging in 1 for n. 1 squared is 1. A2 means we're plugging 2 for n. 2 squared is 4. A3 means plugging 3 for n. 3 squared is 9. A4 means plugging in 4 for n. 4 squared is 16. A5 means plugging in 5 for n. 5 squared is 25. A6 plugging in 6 for n. 6 squared is 36. And the last term, A7, is 7 squared, which is 49. Moving down to our second example, where we plug in n is between 1 and 4, so we will be listing 4 terms. The first term is plugging in 1 for n, negative 1 to the 1 power 3 times 1 equals negative 3. B2, plugging in 2 for n, negative 1 to the second power 3 times 2 will be 6. B3, plugging in 3 for n, 3 times 3 equals negative 9. And lastly, B4, plugging in 4 for n, 3 times 4 is 12. Find the first 4 terms and the 10th term of each infinite sequence whose nth term is given. So we're going to find the first 4 terms, first 4 and the 10th. So A1, plug in 1 for n, and then we evaluate 0.3 times 1 minus 0.4 is negative 0.1. A2 will be 0.3 times 2 minus 0.4, which we will have 0.2. Done. A3 equals 0.3 times 3 minus 0.4, which will be 0.5. A4, 0.3 times 4 minus 0.4, which will be 0.8. And lastly, the 10th term is 0.3 times 10 minus 0.4, which will be 2.6. Another example. Again, we're going to find the first 4 terms. First, we're going to plug in 1 for n, negative 1 to the 1 plus 1, so second power 1 plus 2 squared, which is 1 over 3 squared, which is 9. The second term will be negative 1 to the 2 plus 1. So third power, 2 plus 2 square, which is negative 1 over 4 square, which is 16. A3 will be negative 1 to the 4th power. Then we have 3 plus 2 square, which is 5 square is 25. A4 negative 1 to the 5th power. We have 4 plus 2 square, negative 1 over 36. And the 10th term, negative 1 to the 10 plus 1, 11 power, and we have 10 plus 2 square. So negative 112 square is 144. For any positive integer, and the notation n apostrophe will be n factorial, and n factorial defined by multiplying the numbers starting from n and one less and one less. Very important is, by definition, 0 factorial is 1. So 5 factorial will be 5 times 4 times 3 times 2 times 1. Or sometimes we start from 1 times 2 times 3 times 4 and end with the 5. That's what we need to know about the factorial. So if the sequence is given with the factorial notation, find the first 5 terms of each infinite sequence whose nth term is given. So let's do 5 terms. Plugging in 1 for n, 1 minus 1 factorial, 0 factorial, which is 1 by definition. A2 will be 2 minus 1 factorial, which is 1 factorial, which is also 1. A3 will be 3 minus 1 factorial, 2 factorial, 1 times 2, which is 2. Make some room. A4 will be 4 minus 1 factorial, which is 3 factorial, 1 times 2 times 3, which is 6. And lastly, 5 factorial is 5 minus 1 factorial, which is 4 factorial, 1 times 2 times 3 times 4, which is 24. Next rule is given b to the n equals n factorial over n minus 1 factorial. So let's switch colors. B1 will be 1 factorial over 1 minus 1, which is 0 factorial. Again, we know that 0 factorial is 1. 1 over 1 is 1. B2 equals 2 factorial over 1 factorial. 2 factorial is 2 times 1 over 1. So that will be 2. B3 equals 3 factorial over 2 factorial. So we know that 3 factorial means 3, 2, 1. The 2 factorial is 2 times 1. So these two cancels out. So that will be just 3. B4 will be 4 factorial over 3 factorial. In this case, we know 4 factorial is 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. That cancels out. And lastly, we'll need to find B5, which is 5 factorial over 4 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. These two cancels out, so our answer will be 5. Write a formula for the nth term of each infinite sequence. When we try to write a formula, we try to find some sort of a pattern between the listed terms. It can be some addition or some multiplication or subtraction. So if I want to write these terms, A1 is 1, A2 is 3, A3 is 5, and A7 is, oh, I'm sorry, A4 is 7. So we have to look for some sort of a pattern that if A1 is 1, remember that's like the N is your 1. It's kind of like a function. This would be your input, and this would be the 1, 2, 3 is your input, and the 1, 3, 5 is your output. So you want to check some sort of a relation between the 1 with the 1. We have a 2 with the 3, a 3 with the 5, a 4 with the 7. And it might take you a little while, but in this case, we can recognize that we can see a pattern for an equals 2 times n minus 1. So if we multiply the 1 by 2, 2 times 1 is 2, minus 1 is 1. 2 times 2 is 4, minus 1 is 3. 2 times 3 is 6, minus 1 is 5. 2 times 4 is 8, minus 1 is 7. So we're going backwards when the terms are given, and we have to figure out a rule. Our next rule will be 4 term is given. The first is 14. The second is 16. The third is 18. And the fourth is 20. This time we see some sort of a pattern which might be a little more challenging to find. So you just have to play with some multiplication and addition. This case, if we start with a 12, we can see that it is 2 more, 4 more, and so forth. So 12, and you keep adding some numbers. So if I start with the 12, I can add 2 times 1. So that would be the 14. 2 times 2 is 4. 4 plus 12 is 16. If I put the 3 in here, 2 times 3 is 6 plus 12 is 18. 2 times 4 is 8 plus 12 is 20. And lastly, we have a pattern which is going from between 1 and negative 1. So that could be A1, A2, A3, A4. A1 is positive 1, A2 is negative 1, A3 is positive 1, A4 is negative 1, dot, dot, dot. So the nth term will be, this is to a positive. That means it's to an even exponent, because 1 to an even, negative 1 to an even exponent is positive, negative 1 to an odd exponent is negative. So we have to have n plus 1 power. So A1 will be negative 1 to the second power, which you'll get a positive 1. Negative 1 to the third power will give you a negative 1. Negative 1 to a fourth power will give you a positive 1, and so forth. Lastly, we have the definition of a recursion formula. Gives you the nth term of a function of a previous term. So we find the pattern between the first term or between 2 terms that are consecutive. If the first term is known, then the recursion formula determines the remaining terms of the sequence. So we'll have our first example. Find the first 4 terms. So we're gonna have first 4 and the 8 terms of each infinite sequence given by a recursion formula. So we have that the formula is given, a term will be calculated the previous term squared minus 2. So they gave you A1. first four terms. So we're gonna have to find A2, which will be A1 by the previous term, which is -2 squared minus 2, -2 squared, 4 minus 2 is 2. A3 will be the previous term squared, so 2 squared minus 2, which will be 4 minus 2, which is 2. A4 will be the previous term, which is 2 squared minus 2. So that's going to be 4 minus 2 is 2. Sorry, 4 minus 2 is 2. So we find the first four term. So as we see the pattern, if I keep going, every term ends up being A2. So the 8th term will also be A2. For the other example, they give you formula for the nth term. So the first term is -15. So the second term is the previous term. So it's -15 plus 7. So that will be -8. The third term is the previous term, which is -8 plus 7, which is -1. The fourth term will be -1 plus 7, which is 6. So as we can see, we keep adding 7 to each term. So to get to the 8th term, it will be the 6. That's the fourth term, plus 7, that's 5th, 6, 7, and 8. 1, 2, 3, 4, 28 plus 6 is 34. We kept adding 7 until we reached the 8th term. And this is the end of section 11.1.